Hey guys, part B here, part B. We're now going to start to get into what we need to solve equations. This part you may not need to take notes on. I'm going to add a few things at the end, but I'm just going to go out and list and review all of the stuff that we know so far, the properties, the rules, um, change of base formula, and I'm going to add a few new things at the end. So let's get started. This is going to be a nice short one. This will be long. This would be part B. I can tell you already the smart board is working a lot better on this video. It was kind of acting haywire on part A. So this is the properties, the rules, and the, I don't know what we call them, and whatever, change of base stuff. So let's just go dot. Properties and the rules. All right, so first, this is what we know already. So the first thing is the rule. The rule for logs. Kind of a big deal. Alright? Y equals log b of x if and only if b to the y equals x. Alright? Kind of a big deal. We're going to use that one of logs. Alright. We also talked about a couple days ago the basic properties of logs. These properties are true for any type of log. Could be natural log, could be the common log, could be any base. All right, so there's four of them, just basic properties. Log base b of 1 is always equal to 0. That's because b to the 0 is equal to 1. If I were to change it to exponential form, that's true. All right, if the base of the log is the same as what's inside the log, so b and b, that's always going to be equal to 1. That's true because b to the first power is equal to b. Crazy, I know. Number 3 here. Third one is if we have an exponent inside the log and the bases are the same, it's always equal to the exponent. That's true because b to the y is equal to b to the y. Again, crazy. And the last one is if the log is in the exponent and the bases are the same, that's still equal to y. All right, that's because, well, we know this. All right, whatever. So my point here is though that this is true for any log, including natural log. So I can go through and do the same properties for natural log and say, oops, don't need the base there. Natural log of 1 is equal to 0, and so on. Natural log, again, is just log with base e, with e as the base. All right, let's keep on going. Last class we learned the following. Next one we'll call the product property. All right, the product property, log, doesn't matter what base it is. If two things are being multiplied inside the log, we can split it up and add two logs together plus log of s. All right, the quotient property, same thing, just with minus. So the quotient property, log base b of r over s is log base b of r minus log base b of f. All right, of s is true for any log. And then the last one we learned last time is the power property of logs. Oops. Power property. All right. And this one says that this is kind of a big one. I'm going to start this one. It's used a lot. If I have log base b of x and I've seen the exponent, that c can be written out front of the log. Kind of a big deal. All right. Nice. That was quick. Also from last time is the change of base. Change of base. So I'm going to go off to the right here as an example. Like if I wanted, to find what log base 4 of 2 is. All right, I can't do that directly. I can't type in log base 4 in my calculator. There isn't a key. All I have is natural log and the common log in the calculator. I want to find out what that's equal to. I can use this formula for change of base. So let's go log base, what did I say? Log base b of x is log of x divided by log of a. And I can use any base I want. So this might also be natural log of x or natural log of a. Would also work as well. I don't know why I said a. The base, b. My bad. Alright? So if I wanted to calculate the log of base 4 of 2, the quickest way, I can use common log or natural log. But I can just say, I like using natural log. Natural log of 2, natural log of 4. And that would give me log base 4 of 2. And if you do it on your calculator, this is the same as the common log of 2 and the common log of 4. The ratio is the same. Alright, 2 new things that we're going to use in the next video. These are called, I'm going to call these 1-to-1 properties. And they're obvious. They're obvious properties. But let's just write them down and I can refer to them later. Alright, so the first one is if I have 2 things that have the same base but a different exponent, then obviously the exponents have to be true. They're called the 1-to-1 properties because if the bases are the same, there's only one solution. The exponents have to be equal. It's 1-to-1. All right, and that's true if it's a log too of any base. I'm going to say q and any base v. If the bases are the same in the logs, then u again has to be equal to v. All right, pretty straightforward stuff. We're going to use this to solve equations in the next video. Awesome.